Assalamu alaikum wa rahmatullahi wa barakatuh. Students, today we are starting another part of chapter triangles. We are starting exercise 6.3. Have a look. Question number 1. Question number 1 says, state which pair of triangles in figure 6.33 are similar. Write the similarity criterion used by you for answering the question, and also write the pairs of similar triangles in the symbolic form. So it's a simple question. For example, let me have the first one. You have one triangle, you have another one. This triangle is ABC. This is PQR. 60, 80, 40, this is 60 degree, 80 degree, 40 degree. For this is 60, 80 and 40 degree. That's simple. In triangle ABC and triangle PQR, since angle A is equal to angle P, why? Because both are 60 degree. Angle B is equal to angle Q, 80 degree both. Angle C is equal to angle R, both are 40 degree. Therefore, you can say triangle ABC is similar to triangle PQR by angle similarity criterion. Because so far we are done with 3 theorems in which we can prove whether two triangles are similar or not. That is AAA, angle similarity criterion, or angle similarity criterion. That's one of the same thing, because we just learned about that in the previous part, that if two angles are equal, then by default the third angle is also equal. So angle similarity criterion is also angle similarity criterion, number 1. Number 2, SSS. Angle means when 3 angles of one triangle are equal to 3 angles of another triangle, then the triangles are similar. Then SSS, 3 sides of one triangle are in proportion with the 3 sides of another triangle. Then we have SAS. One angle is equal to another angle of other triangle, and the included sides of that angle are in proportion. That is SAS. So far we have 3 similarity criterion: side, angle, and side, side. Here, what you observe? 3 angles are equal, so by angle similarity criterion, triangles are similar. Remember one point here. For example, if you have triangle like this, and suppose triangle like this, if this is ABC, PQR, in the following questions, remember this point. For example, if this angle is equal to this angle, and this angle is equal to, say, this angle, and this angle is equal to this angle. Now here 3 angles are equal to the 3 angles of this triangle, but you cannot say triangle ABC is similar to triangle PQR. You cannot say this here. It's not so. This is invalid expression. Why? Because if you say triangle ABC is similar to triangle PQR, that means corresponding angles are equal, and corresponding angle means angle A corresponds to P, angle B corresponds to Q, angle C corresponds to R. So had it been the case, then A would have been equal to P, B would have been equal to Q, and C would have been equal to R. But here A is equal to what? A is equal to Q. So you can say triangle ABC is similar to A is equal to Q. So triangle Q, B is equal to P. So P and C is equal to R. So you can say R. Hence triangle ABC is similar to triangle QPR. It seems that there is no difference in triangle PQR and triangle QPR. Yes, there is no difference at all in this triangle, writing this triangle and this triangle. But when you show the similarity, you have to keep note of this point, that corresponding angles must go together. Got it? So keep this point in mind. Okay, so you got triangle ABC is similar to triangle PQR by angle, similarity criterion. Now, this was the first part. Now I'll leave rest of the parts to you. These are the same parts. You can do it in a similar way. Now let me show you question number 2. Question number 2 says, in figure, let me draw the figure. Have a look. Question says that ODC, O here is O. ODC, triangle ODC is similar to triangle OBA. ODC is similar to triangle OBA. Yes. Then angle BOC is equal to 125, CDO is equal to 70 degree. You need to find DOC. You need to find DOC. DOC is this angle. You need to find this angle. You need to find DCO. DCO this angle. And you need to find OAB. OAB is this angle. You got it? So let us find all these angles. Okay, what is given? What is given? Triangle ODC is similar to OBA. ODC is similar to triangle OBA. Such that angle BOC is equal to 125 degree and angle ODC, angle CDO, angle CDO is equal to 70 degree. This is given. To find, what you are going to find? Three angles. DOC, DCO. Angle DOC, angle DCO, and angle OAB. So these are the three required angles. See, first of all, what we can do, find DOC. DOC. This angle. Now if you see, this angle and this angle makes linear pair, so you'll get easily this angle. Alright, since angle DOC plus angle BOC is equal to 180 degree, reason is LPA, linear pair axiom, which implies that DOC, keep it as such, plus BOC is 125 degree, is equal to 180 degree. Then angle DOC is equal to 180 minus 125 degree. Therefore, angle DOC is equal to, then you can do the subtraction, that is 55 degree. That is your DOC. So we got the first one. Now DCO. DCO you can apply Angelson property in this triangle because two angles are now known. Then apply the Angelson property, you'll get the third one. In triangle ODC, since angle CDO plus angle DOC plus angle DCO is equal to 180 degree, and reason is angle sum of triangle. This is the angle sum property of a triangle, which implies that CDO is 70 degree plus DOC we just got 55 degree plus angle DCO is equal to 180 degree, which implies that providing this you'll get 125 degree plus angle DCO is equal to 180 degree, which implies that angle DCO is equal to 180 minus 125 degree. Therefore, angle DCO is equal to, now do the subtraction, you'll again get 155 degree. So DCO is also 55 degree. Now all you need to find is OAB. OAB. Now pay attention. Since triangle ODC is similar to triangle OBA. Here it's already given ODC is similar to triangle OBA. It is given. We just learned, had it been the case that this triangle is similar to this triangle, then O is equal to O, D is equal to B, and C is equal to A. So ODC, so C is equal to OBA. This C is equal to this A. Got it? Which implies that, then I can say angle DCO is equal to OAB. Angle OAB. Why? It is CAST. Corresponding angles of similar triangles. They are equal. Therefore, angle OAB, now DCO is 55 degrees, so OAB is also 55 degrees. Here you are. So all the required angles are equal to 55 degrees. Then you can say angle DOC is equal to angle DCO is equal to angle OAB is equal to 55 degree. You got it? Hence found. That's it. Make a note. Now let's start question number 3. Question number 3 says, if figure, let me draw the figure. We have a triangle like this. Question says, in this figure, QR by QS is equal to QT by PR. So, given a triangle QTR, in which QR by QS is equal to QT by PR. QT by PR. And angle 1 is equal to angle 2. And angle 1 is equal to angle 2. This is given. Now see, QR by QS is equal to QT by PR. And angle 1 is equal to angle 2. Angle 1 is, this angle is angle 1 and this angle is named angle 2. This PRQ angle 2 and PQS or TQR is angle 1. Now you need to prove that triangle PQS, to prove triangle PQS is similar to triangle TQR. This is your target. PQS is similar to TQR. See. First of all, angle 1 is equal to angle 2. So side opposite to these angles are equal. In triangle PQR. In triangle PQR. In triangle PQR. Since angle 1 is equal to angle 2, angle 1 is equal to angle 2. This is given. Which implies that, so side opposite to angle 1 in triangle PQR, opposite side to angle 1, that is PR, is equal to side opposite to angle 2, that is PQ. So this is equal to this, PQ. Now write the reason. Sides opposite to equal angles. So PR is equal to PQ. PR is equal to PQ. Now after that, what we can do after that, now use this thing. Also QR by QS is equal to QT by PR. This is again given. This is given, which implies that what I'll do, let us replace this PR with PQ here. So QR by QS is equal to QT by, instead of PR, I'll write PQ. PQ or QP. That's one and the same thing. So I'll give the reason as PR is equal to PQ. Got it? Now see, QR by QS, QR by QS is equal to QT by QP. QR by QS is equal to QT by QP. Got that one? Now consider triangle PQS and triangle TQR. Consider these two triangles since PQS, so this triangle, TQR. Now angle Q is in both PQS and TQR. You can say since angle Q is equal to angle Q is equal to angle 1, this is common. Got that? Common. Then you can say QR by QS is equal to QT by QR by QS is equal to QT by QP. Proved above. You just proved above that QR by QS is equal to QT by QP. I think you got it. That one angle of one triangle is equal to another angle of another triangle, and the side included these sides included this angle are in proportion. You see, angle 1 is equal to angle 1 and included sides are in proportion. So by side equal side, triangles are congruent. Therefore, triangle PQS, similar, not congruent, is similar to triangle TQR by side angle side similarity criterion. So you are done. PQS is similar to TQ. Hence, proved quadrilateral demonstrandum. Kindly make a note. Now after that, question number 4 says, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Question number 4 is easy question, I'll leave it for you. Question number 5. Question number 5, you can prove all 4 parts by angle-angle similarity criterion, so I will leave it for you. Question number 6, let me show you question number 6. CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on the side AB and FE of triangle ABC and EFG. So we have 2 triangles ABC and EFG. If triangle ABC is similar to FEG, so let us make 2 triangles which are similar, that is ABC and FEG. Let us say this is A, B, C and FEG. FEG. ABC is similar to FEG. So what is given? Triangle ABC is similar to triangle FEG. CD is the bisector of ACB. CD is the bisector of ACB. So it's like this. So this is D. CD is the bisector of ACB. Bisector means this angle is equal to this angle. You got it? And GH is the bisector of EGF. GH is the bisector of EGF. Goes like this. So here this angle is equal to this angle. This is H. D and H lie on AB and FE respectively. So D lies on AB, H lies on FE. So we are good so far? Okay. ABC is similar to FEG. What's given? Anything else given? Yes. That this angle is bisector of this angle. Let me name this as 1. This as 2. Let us name this as 3. This as 4. So what can I say? Triangle ABC is similar to triangle FEG, where angle 1 is equal to angle 2 and angle 3 is equal to angle 4. What we are going to prove? We are going to prove 3 things. Number 1, CD by GH. CD by GH is equal to AC by FG. CD by GH is equal to AC by FG. Number 2, triangle DCB. Triangle DCB is similar to triangle HGE. And number 3, triangle DCA is similar to triangle HGF. These are the things what we are required to prove. Let us start with the very first one, that is CD by GH. CD by GH is equal to AC by FG. So, on observing that CD by GH is equal to AC by FG, we are going to consider this triangle and this triangle. Consider first of all, I'll write one thing. Let us use this one. Since triangle ABC is similar to triangle FEG, this is given. In that case, I can say now corresponding angles are equal if the triangles are congruent. So I can say angle C is equal to angle G. Yes. So my C is angle ACB. Angle ACB is equal to angle FGE. How? CAST. Corresponding angles of similar triangles. Now, which implies that half of angle ACB is equal to half of angle FGE. Why? You know, it's the Euclidean postulate that when wholes are equal, halves are equal. Yes. So, wholes are equal, halves are equal. Got that one? Yes. Then half of angle ACB is angle 1. Therefore, angle 1 is equal to half of angle G is angle 3. Why? Because CD and GH are bisectors. As CD and GH are angle bisectors. Got that one? Now, so angle 1 is equal to angle 3. Now let us consider this triangle and this triangle. Now consider triangle ACD, or I can say DC, let us name this DCA. Consider DCA and triangle HGF. DCA, HGF. Consider these two triangles. What you observe here, since angle A is equal to angle F, Y cast for triangle ABC is similar to triangle FEG. What do we mean by that? Since ABC is similar to FEG, that means if you do the cast for that corresponding angles of similar triangles, so A is the corresponding angle of with F for these two triangles, so that means angle A is equal to angle F. Number 2, we can say angle 1 is equal to angle 3. Proved above. Proved above. We just proved angle 1 is equal to angle 3. Therefore, triangle DCA is similar to triangle HGF by angle-angle similarity criterion. Then, if that is the case, these two triangles are similar, so corresponding sides are in proportion. Then I can say CD by, now from this triangle I'll take CD by GH is equal to, we learned yesterday that whatever suit you take from this side, you have to take the same from this side. Like if I take CD, I'll take GH. Then if I take AC, I'll take FG. So CD by GH is equal to AC by FG. That's it. So we proved the first part. CPSC, corresponding parts of similar triangles. Then we have the next one, part number 2. DCB is similar to HGE. Consider these two triangles. Consider triangle DCB and triangle HGE. Since DCB, HGE. So these lower triangles. Here what you got? Angle B is equal to angle E. Same reason, cast for triangle ABC is similar to triangle FEG. Got that? Then angle 2 is equal to angle 4. Angle 4 is equal to angle 4. As angle 1 is equal to angle 2, these are the half we took here, then the rest of the half is this. So I can write reason as angle 1 is equal to angle 3. You got it? Or you can write reason half of angle ACB is equal to half of angle FGE. Got that one? Therefore, triangle DCB is similar to triangle HGE. Again by angle-angle similarity criterion. Got it? So you are done with part number 2 as well. Now part number 3, triangle DCA is similar to triangle triangle HGF. We already proved that in part 1. DCA is similar to HGF. You can write proved in first. So you prove all these, so hence proved quadrature demonstrandum. You got it? Now let's have the question number next. Seventh question. Sides AB and AC and median AD of triangle ABC are respectively proportional to the sides PQ and PR and median PM of another triangle. Show that triangle ABC is similar to triangle PQR. So you have two triangles. Let us say these are the two triangles A, B, C. ABC and PQR. PQR. AB, AC and median AD. We have in this triangle median AD. This is AD median, and here PM is median, AD and PM are median. Sides, now see, sides AB, AC and median AD are respectively proportional to the sides PQ, PR and median PM of another triangle. Show that ABC is similar to PQR. You need to show ABC is similar to PQR. So let's write down given. What is given? Triangle ABC and triangle PQR in which AB by PQ is equal to AB by PQ is equal to AC by PR is equal to AD by PM. Where AD and PM are medians over BC and QR respectively. BC and QR respectively. To prove what we are going to prove, triangle ABC is similar to triangle PQR. Let us do a bit construction. What I'll construct, now it's okay. Now see what I'll construct. I'll extend AD. Extend AD to X such that AD is equal to dx. So extend AD equal to A, such that extend AD equal to AD. So AD is equal to dx. Do the same thing here. Extend PM to Y such that PM is equal to MY. You got the construction? And hence join BX CX. Similarly join QY and RY. Got it? So I'll write extend AD and PM to x and y respectively, such that AD is equal to dx and PM is equal to my. Got the construction? Now let us have the proof. What I'll do, see, ABXC is no doubt a quadrilateral because we have 4 sides, isn't it? So let us use this quadrilateral. In quadrilateral, this is a quadrilateral ABXC. ABXC. What you have in this quadrilateral, BD is equal to DC. Since BD is equal to DC, why? BD is equal to DC? Because AD is a median, yes. As AD is a median. As AD is a median. What else do we have in this quadrilateral? AD is equal to DX. Why? By construction. By construction. Now what we got? In this quadrilateral, AX and BC diagonal is bisected. So diagonals bisect each other in this triangle. This is equal to this is equal to this. That means bisects of the diagonals of this quadrilateral bisect each other. So therefore I can say that ABXC is a parallelogram. ABXC is a parallelogram. Why? As diagonals bisect each other. Similarly, you can prove PQYR is a parallelogram. How? Again, you can do the same thing. PM is equal to MY by construction. QM is equal to MR as PM is a median. Similarly, so write down similarly PQYR is a parallelogram. Same reason. Then I can make one thing, that AC is equal to BX, then AC is equal to BX and PR is equal to QY. Why? Yes, opposite sides of a parallelogram. Opposite sides of a parallelogram. So far so good. So now we are at this point that this side is equal to this side and this side is equal to this side. Now what we got from that? Let us use this now. Now AB by PQ is equal to AC by PR is equal to AD by PM. This is given. So, which implies that, what can I do? AB, keep it AB, divided by PQ PQ, AC, replace AC by BX because AC is equal to BX, we just proved that. AC is equal to BX, so replace AC by BX. PR, replace PR by QY is equal to AD by PM. Let me write twice AD by twice PM. AB, I kept it AB, PQ, PQ. Now I replace AC by BX and PR by QY because we proved that, yes? Now here I multiplied and divided 2. That will make no difference whatsoever. So 2 gets cancelled again, so we'll get the same AD by PM. But we'll get one benefit by this. You can see. Now, which implies that, so here what I'll write, AB by PQ, AB by PQ is equal to BX by QY is equal to, now twice AD, twice AD is AX because AD is equal to DX, so twice AD is AX divided by twice PM is PY. You got it? So AB by PQ is equal to BX by QY is equal to AX by PY. Now what you got from that? See, AB by PQ is equal to BX by QY is equal to AX by PY. So you got triangle, therefore triangle ABX is similar to triangle PQY. Why? Because all the three sides of this triangle ABX are in proportion with all the three sides of PQY. You can see AB by PQ, this side, BX by QY, this side, and AX, PY. So all three sides are in proportion, so we can say ABX is similar to PQY. You write, how you got that? By SSS similarity criterion. All the three sides are in proportion. So by SSS similarity criterion, we got ABX is similar to PQY. Now, in that case, I can say, which implies that, or then I can say this angle is equal to this angle, because this triangle is similar to this triangle, so this angle is equal to this angle, CSC. Then angle BAX is equal to angle QPY. Reason? CAST, corresponding angles of similar triangle. Yes. Now pay attention. You just started here with the opposite sides of parallelogram, this side and this side, and you use this side and this side. If you would repeat the same procedure on this side and this side, and this side and this side, because these are again the opposite sides of a parallelogram, what you will get here, at the end, you will get this, again see, this side is equal to this side, so you will get ACX is similar to PQY, and that you will get this angle is equal to this angle, this one. You will get this angle equal to this angle. So under similar procedure, you will get this angle is equal to this angle. So I'll do similarly. Similarly, angle CAX is equal to angle RPY. RPY. This is the similar argument. Good. Now adding these equations, what you'll get, which implies that angle BAX plus angle CAX is equal to angle QPY plus angle RPY. You got it? Adding this equation and this equation. So BAX plus CAX is equal to QPY plus RPY. What you got for that? BAX plus CAX. BAX plus CAX is nothing but angle A. Therefore, angle A is equal to QPY plus RPY. It's angle P itself. So you got angle A is equal to angle P. Yes. Now consider triangle ABC and PQR. Consider triangle ABC and triangle PQR. ABC, triangle PQR. What you have? You have, since angle A is equal to angle P. Proved above, angle A is equal to angle P. What else you have? You have AB by PQ is equal to AC by PR. AB by PQ is equal to AC by PR. It's given. Okay. Therefore, what you can say, see, one angle of one triangle is equal to another angle of another triangle, and the sides including these angle are in proportion. AB by PQ is equal to AC by PR. So according to theorem 6.5, that is side angle side similarity criterion, we got triangles are similar. Therefore, triangle ABC is similar to triangle PQR by side angle side similarity criterion. Hence, proved. Quadratic demonstrandum. Make a note. Now let's have question number 8. Question number 8 says a vertical pole of length 6 meters. We have a vertical pole just like this of length 6 meters. Vertical pole of length 6 meters. Casts a shadow 4 meters long. This pole casts a shadow. Now shadow we show on the ground like this. This is 4 meters long. And at the same time a tower casts a shadow. At the same time a tower. So we have a tower cast as a shadow. Tower cast as a shadow 28 meters long. This is a tower cast as a shadow 28 meters long. Find the height of the tower. You are required to find the height of this tower. You got it? If I just join this, what we'll get? We'll get two right-angled triangles. Let us name them A, B, C and say P, Q, R. Here what you observe here, given. Okay, what is given? You can write triangle ABC and triangle PQR right angled at B and Q respectively, in which AB is equal to 6 meters, BC is equal to 4 meters and QR is equal to 28 meters. This is given. To find, what you are going to find? Length of PQ. So PQ is what you are going to find. Solution. Consider these two triangles ABC and triangle PQR. Since angle B is equal to angle Q, yes, each 90 degrees. What else we have? We have angle C is equal to angle R. Angle C is equal to angle R. Now pay attention, what is the reason for this angle C is equal to angle R? I am saying this angle C is equal to angle R. How would you say that? See, question says shadow is formed at the same time. At the same time means shadow is from the source for the shadow formation is, obviously in this case it's a sun. So angle formed between the rays of sun, this is the rays of sun, and the shadow, at the same time, that's always equal. So for example, if you take two objects, two objects of different height, and if you observe, if you keep them vertically on the ground, two different objects, and if you observe the shadow formation by the sun at the same time, so it will be absolutely equal to, it will be exactly equal to each other, got it? So angle C is equal to angle R. Sorry, shadow is not equal, it's my fault. Shadow is not equal. The angle formed between the rays and the shadow, that will be equal. So this angle is equal to this angle. So angle C is equal to angle R. So this is angle formed by the sun at the same time. At the same time. Therefore, what we got from here? Therefore, triangle ABC is similar to triangle PQ by angle-angle similarity criterion. Then what we can conclude from that, if triangles are similar, then the corresponding sides are in proportion. Then I can say AB by PQ is equal to BC by QR. This is CPST, corresponding parts of similar triangle, which implies that now AB is 6 divided by PQ is, we need to find that, BC is 4 and QR is 28. Now this is 6 by PQ is equal to 4 ones, 4 sevens, that is 1 by 7. Now 2 invertendo, PQ by 6 is equal to 7 by 1. That's invertendo, or you can say I'm taking reciprocal from both sides. Therefore, PQ is equal to 6 meter. Cross multiplication simply, and that's your answer. That's your answer. Now let's have the next question. If AG and PM are medians of triangle ABC and PQR, respectively, where ABC is similar to PQR, so we have two triangles. We have two triangles ABC and PQR. These are similar triangles. Okay, so what is given? Triangle ABC is similar to triangle PQR, where AD and PM are medians. We have to prove AB by PQ is equal to AD by PM. Let us consider this triangle and this triangle. Consider triangle ABD and triangle PQM. Let us consider these two triangles. What you have in these two triangles, since I can say angle B is equal to angle Q. Angle B is equal to angle Q. Why? Cast for, since ABC is similar to PQR, so this is the corresponding angle. These are the corresponding angles for this similarity. So angle B is equal to angle cast for triangle ABC is similar to triangle PQR. Got that one? One more thing we have, AB by PQ. AB by PQ is equal to BD by QM. BD by QM. How? See, ABC is similar to PQR. So AB by PQ is equal to BC by QR is equal to AC by PR. Corresponding parts of similar triangle. Sides are in proportion. So BC by QR is equal to AB by PQ. Now BC can be written as half of BC by QR can be written as half of BC by half of QR, and half of BC is, I'll give you the reason for this. See, AB by PQ is equal to BD by QM. I'll write like this, since triangle ABC is similar to triangle PQR, this is given, which implies that then AB by PQ is equal to BC by QR, CPST. CPST, yes, which implies that then you can write AB by PQ is equal to half of BC by half of QR. Yes, we can say that, which implies that AB by PQ is equal to half of BC is BD divided by half of QR is QM. Why? As AD and PM are medians. As AD and PM are medians. You got the reason? So that's the reason of this. AB by PQ is equal to BD by QM. Triangles is similar, then sides are in proportion. Then half, write down for this half. We can write, there's no problem in that, because half and half gets cancelled, you get the same result. Now half of BC is this because of the AB and PM are medians, therefore you can say half of BC is BD and half of QR is QM. So by this what you got? This triangle for this triangle and this triangle, angle is equal and the sides including these angles are in proportion, so these are similar. Therefore, triangle ABC is similar to triangle, not ABC, ABD. ABD is similar to triangle PQM by side angle side similarity criteria. Got it? Yes. Then you can say one thing, that then AB. Now this triangle is congruent, similar to this triangle. So AB by PQ will obviously equal to AD by PM. Because now all the three sides are in proportion. AB by PQ is equal to BD by QM is equal to AD by PM. So I can use AB by PQ is equal to AD by PM. CPST. And that's it. We are done. AB by PQ is equal to. We were required to prove AB by PQ is equal to AD by PM. We are done. Hence proved. Quadrilateral demonstrandum. Make a note. By this you are done with exercise 6.3. So inshallah in next part we'll start theorem 6.6. I'll see you next time. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.